I guess the most puzzling question is what's inside a black hole? They're just holes in space, and we don't know what could be in them. And the laws of physics break down inside a black hole, and we don't know what to say about it.
I am not sure the mathematics exist already that we will need to describe physical reality in a realm beyond where space and time have any meaning. But we should try.
We can still try to figure out by indirect scientific means, thought experiments, deduction, mathematical consistency, many other procedures, all the tricks that the scientists have in their tool bag to figure out what's inside there.
People pontificate about what happens in the interior, that inside there is something called a singularity. And this was recently awarded a Nobel Prize in physics to Roger Penrose for his really beautiful work on this in the 60s, where he showed that collapse to form the event horizon is inevitable, and that once the event horizon forms, so let's say you have a star that's collapsing and it gets so small that the space-time is so strongly curved around it that not even light can escape, then we say a black hole has then formed. The event horizon, which is that region beyond which light cannot even escape, is like an archaeological record on the space-time, but then the star continues to fall, the material of the star. The light from the star itself can no more escape than anything else can, and it begins to fall catastrophically inward. And then the inevitable endpoint is that something that's known as a singularity forms, a region of infinite space-time curvature, infinite density.
Inside of a black hole, there are singularities. A singularity is a region where the pull of gravity is so intense, the warping of space and time are so intense, that anything that falls into it gets destroyed. It is a place where Einstein's laws of relativity break down, and the new laws, called the laws of quantum gravity, come into play. They control what goes on.
So this would be similar that if you would look somehow out in the street, and all of a sudden there is like an edge in the middle of space that distorts things so much that you cannot even move past it, and it would distort things so much around it that you somehow would see everything that is behind it in front of you. So that's a property of black holes, a singularity.
Inside of a typical black hole like the one like Gargantua in the movie Interstellar, there are 3 singularities we now understand, and so it's a very rich interior.
And most people believe that that will not actually happen. That's the inevitable consequence if we only discuss space-time. But if we acknowledge that the star is made of stuff, and the stuff has quantum properties, it's very likely that the singularity will not form.
This is a property that we don't even know if it actually exists, because we cannot look past the event horizon. And plus, as physicists, we don't even believe that such thing could happen, because it means that something is really like infinite. It's not smooth, it's a singularity. So it also indicates this existence of singularity as described by Einstein's equations, that Einstein's equations are not the final story, and they have to be combined with other things like quantum mechanics to solve that exact problem. So 2 things can be the case. One is that Einstein's equations are not enough. The other thing is that our model of the black hole is just not good enough. Maybe there is a different way of describing what's inside that does not involve the existence of a singularity. There's 2 possibilities. But of course, because we have no idea what's inside the horizon, we cannot say anything about it at the moment.
There's a lot of debate about what the alternative is. There's this idea that, okay, a black hole forms, it collapses, everything goes into the singularity. Then there's this inverse image of the singularity of a Big Bang, where it seems like the mirror image, where everything comes out and nothing goes back in. And so people have attempted to sew them together and ask the question, which is really, quite appealing in a lot of ways. At the center of a black hole, instead of a singularity, do you have a white hole, which leads to a big bang, which leads to a new universe? And so even if the black hole is only 30 kilometers across on the outside, is there an entire universe on the inside? Because they can be bigger on the inside than they are on the outside. And that's very elegant. But again, it's not the most popular argument out there for very subtle reasons having to do with the quantum laws, but it is very appealing in its own way. I think the craziest ideas out there right now may be the most promising. And so there are ideas that, let's say matter falls in, creates a black hole. The black hole begins to evaporate through a very subtle quantum process that Hawking taught us. And then there's this argument, nothing comes out of the black hole, yet it evaporates and disappears. And it's as though the curtain is yanked up, and where did all the stuff go that fell into the black hole? This has been a long-standing argument since the 1970s because of Stephen Hawking's work. And the craziest idea is that the particles the black hole radiates are connected by quantum wormholes to the particles that fall in, so that they're actually like the same particle. And those quantum entangled wormholes actually create the phenomenon of the black hole in the first place. The way I like to describe it is, imagine you're doing embroidery with thread, and from far away it looks like a black hole. You've made this perfect object, but up close you realize it's just this entangled thread. And in some very subtle way, that's what the quantum entanglement argument is like, that it's really, the black hole actually emerges by the entanglement of these pieces of thread, that is to say, quantum wormholes, that are negotiating between the inside of the black hole and the outside of the black hole. So I think that is the craziest argument, but I think it's probably the most promising.
Figuring that out is a scientific problem of the deepest kind. It's not one where we have a roadmap to understanding it. It's very puzzling. It has a contradictory nature. It's not like if we just keep doing some computation or some analysis or build a bigger telescope that then we'll know the answer. It's a puzzle, and we don't know what the right approach is that will solve it.
That's the overarching challenge. Can we get to a complete understanding of the universe, to an understanding of physics beyond where our notions of space and time are valid? It's a very deep question. Is there a frontier to physics, or can somehow science provide us with a complete understanding of the universe? It comes down, I believe, to boundless imagination and creativity.